Okay, one of the things I forgot to mention, and I was trying to get to before, is, when, remember when we did that bottom layer? Let me enable it. Okay, and I chose to do 2 passes. You have this combined thing. If you don't have that checked, what will happen is for every pass, it'll generate a separate file, a geometry file for it. But by hitting combine, it combines all passes into one operation, which is normally what you want to do. There's no real good reason most of the time to have that as a separate file here, so you'd have to generate separate CNC processes for it. But sometimes you might want to change tools. That's, I think, why they do that. So you could actually use like a different size router for your first pass versus the second pass. So that's why you would probably want to uncheck that combine if you're going to use 2 different size tools for each pass. Okay, so you got pass 1, you use one size tool, pass 2, you use a second size tool. Well, since they're set up as separate objects, you can generate separate CNC files for those to, yield a different result. So that allows you to kind of, at least do those separately. But I still don't know why you'd want to do that, because that still doesn't make sense, because I don't think you could easily do that. But I mean, again, you could probably set it up by tinkering with the, the percent pass overlap, so I could put it like maybe a negative percentage or 0 or something, and anyway. Point is, if you don't press that, it will generate 2 separate objects, and usually you won't want that, because then you'll have to do 2 separate CNC files for what probably is no good reason. So, because again, I'm not sure that it would even be that useful for changing tools now that I think about it. Because, generally, wouldn't those be a different size? So you're kind of stuck with one size, with this system. But at any rate, just make sure that thing's checked, because it's just a pain in the ass if it's not checked. But again, you can set it up in the edit preferences thing to do that. Again, if you want to see again what my preferences are in this is what they are. Just look over them quickly, and then look at your default version if you just installed Flatcam, and see how it differs. And you'll see sort of what I did, and you can kind of work out why I made some of the changes I did. Again, this is for Gerber objects. This is for, Gerber objects are here. This is for Exelon, so that applies to things here on this tab. Geometry is for this layer, so things on this layer apply to this tab. And CNC jobs is this tab that will apply to. But then you're talking tools. So specific tools, I still haven't figured all this out, but I do have differences in what my settings are versus what the defaults are. So, so you can compare them all here. But then you got a tools 2 over here. I'm still not quite sure. I haven't, I'm not an expert user of this program yet. Because again, I've only done, on this 3018, I've only done like a little over a dozen circuit boards so far, and most of those have been single-sided, just one double-sided. Like I said, even though I have a vast history of making my own circuit boards, still, this stuff is, kind of learning for me like it is, or maybe for you if you're watching these videos. But at any rate, I just wanted to show you that. Yeah, I think this whole program's almost exclusively written in Python, so almost all of it's a bunch of Python scripts. So if you know Python, you can kind of go probably make modifications, but you still have to figure out how the program is work, how this person, organized it and everything. But anyway. But that does it for Flatcam. And again, I did make a separate little video you'll see in the, if you look, I'll have a link to it in the description down below. So, it discusses the software itself and its installing it and all that a little bit. So you might have a look at that if you're interested. But at any rate, yeah, we got to get into this candle at this point, since we've already got the CNC stuff all generated. So the first thing I'll do in candle, okay, I'm not saving that since that was bogus. Let's see. Hardware. Height map. Oh, that's we're doing the height map mode. Okay. Alright, that gets us started. Okay, so the first thing I'll start with, since we're going to be doing the bottom layer first, it's the layer we mirrored earlier, but this represents most of what we need a height map for, so I'll open this first, right? So, I have it open in Candle, but we are going to want to create a height map. Now, the first operation I'll actually do is to drill our 2 reference holes that we generated in Flatcam. These things right here. So that's the first operation we'll perform. But before we do that, and that's why, like I said, if you wanted to look at it, I've actually got that's where my 42 mil drill bit went. That's why I couldn't find it. I had it actually in the spindle there. But that's the first tool I actually use, is drilling those 2 reference holes. But the first thing we need to do, though, is actually make a height map, and it doesn't really matter what tool you make a height map with. So so anyway, that's, damn it, stupid square. What the fuck is that anyway? Piece of shit. Microsoft's such a bunch of dipshits. Okay, but yeah, anyway, the fact of the matter is minimize that. And minimize this. Okay, so, but basically, yeah, I'm going to use my drill bit to probe for the height map, but I open this copper layer because that's the area we want to probe. That's what's most important that we make a height map of, is this actual copper zone. So, you come over here to your height map, you hit create, okay, and that brings us in here, but then you come down here and hit this auto button, okay, and that actually sizes it to the actual copper, so that's where it's going to probe. Okay, and all these little ticks you see here, these are your grid. Now, when I was probing my board the other day, I set it to 10 by 60, but that's actually way more than I need. I probably, want to do like a 30 by 10 would be fine, because the board is about, I showed you this already. It's I don't remember if I have, since I made some of these fucking versions in that video. Yeah, the board is about son of a bitch. Stay there. Okay, so our board is about 5.9 inches by 2.3 inches. So 2.3 inch means 2.39 is about 2.4 inch. So it's about every 2.4 inches, since I got 10 across, 10 along the x-axis, which is here, that means it'll be 10 divided into 2.4 inches. So it's about every quarter of an inch it'll do a test point. So, in order to maintain that, you want, since this board's about 6 inches, if that was 4 test points per inch, it'd be, 24 test points. The 30 will be fine, so it'll take a little, it'll take a little longer. But still, I don't want to risk it, because this is such a high density board that, normally I just do like an 8x8 or something like that, but for a board this size, you certainly want to make it bigger, and I just don't want to take any chances given how elaborate this is. It's a lot of work to fuck up. So that's why I'm trying to use more points than normal. But, normally I might use an 8-point across for a 2-inch wide board, and then about 8 points for every 2 inches vertical. So, there's 4 points per inch, so it still ended up being about 24. So, but here I'm going to go ahead and leave it at 30. Again, we've autoed it. This interpolation grid, don't worry about it. My understanding is that's the grid it actually forms between the points it probes for interpolation purposes. So it's trying to guess at the heights in between these points, and it forms a, kind of a surface like a net. You'll see that form as it goes. But now I've already set the z-axis yesterday. So if you go here, I set it up to where this button, and I'll show you the G codes I assigned to it. Let me the settings thing. And when you're using your scroll wheel on your mouse, do not scroll in the middle. It'll start grabbing these things and fucking changing them as it hits it. You could be changing settings and not know it because you're scrolling it, and it's so be careful about that. Scroll along the sides or use these tabs over here. But here's the user buttons, so you can actually program them with G code you want. And this is like an emergency stop button, because there's no fucking emergency stop built into this stupid machine by default. But you can probably wire one up, using one of the limit switches, I assume, but I haven't gotten around to doing that yet. This has to do with resets, because sometimes this thing will crash on you, and you gotta try to wake it back up, and I use these two commands for that. But this is a homing command, so because this stupid machine doesn't have that built into it either, where you've got a button you can press for it to home, to go to your set home. Every CNC program I've ever seen has that in it. But at any rate, this doesn't have that in it. So let me see if I can arrange this thing so you can kind of see what's going on. But I got my home setting down there, so I'm going to go ahead and push this button. Oh, it may have been screwed up. Well, that's good. It may have been screwed up since I kind of closed this thing earlier, I think. Alright, so let me go and try to set this up. Maybe I should make this smaller. Might be harder for you to see, but close this so that shit doesn't happen. Okay, but I'm going to try to aim for, about there. Let me lower the bit so it's easier to see. I usually use my magnifying glass a lot when I'm trying to do this part of it. I wish the camera focusing this was better. I don't know if there's any way of adjusting this or not. Damn it. I guess it does have a little bit of focus right now. That's good. Okay, but yeah, I just try to get it to where it's you know, because remember we have, you know, our origin is inset, but I want to get it as close to this, hold on. I want to get it to as close, you know, because unfortunately, because I put that solder joint there, you know, that's a bad place. I really don't want my tools to run into it, even though it probably wouldn't hurt them. It's still, solder is such a soft metal, it can gum them up. So it's better not to route through solder if you can avoid it. But what I like to try to do is to get it, you know, it's home as close as possible. But see right there, our router bit will end up going through it. So I'd like to move it over a little bit. So, and understand this, even though I've got the machine coordinates I got set to read out in mils, you know, inches. Still, this shit over here is in millimeters. So, so you know, and so is this whole grid thing. It's in millimeters too. So, you know, these idiots didn't, you know, think people needed to have consistent units when they're working for this. That's what crashes NASA's space probes into Mars. But, you know, the fact of the matter is, you know, we need to, you know, let's try shrinking this a little bit. Yeah, that's why I don't like doing that. It covers my controls. I'll put that over there, and maybe this over here will help. Anyway, yeah, that should be okay. I don't mind if my router bit goes through it a little bit, but at least none of my V-score routers or drills or anything will run into it, but the edge routing bit will, you know, probably nip it on the side. But at any rate, so that's where I kind of want it. I don't want it any further left than that. Okay, but, you know, then this, that's probably a little closer, because remember, that's inset by 50 mil too, so I'll go just a little more, you know, even that's probably more than I need, because it really doesn't hurt if the router bit, you know, comes out on the side, but still, it's best to, you know, try to leave some kind of a little lip on it. So, well, but that's why I had to shorten the boards because of that. So, so I'll stick it back there. I think that'll probably be okay. Hold on, let me make sure that. Well, let me go ahead and zero it right there to that point. Now let me. Okay, so it can go out quite a bit over the edge of the table there. So I don't think it'll crash my machine at that point, although I can't guarantee it won't. Yep, that is crash machine. That's what happens when your stepper motor misses a step. So that's as far as I can go. So let me zero it there. All right. And then I want to make sure, because we said our tool on this is 100 mil, right? Okay, and then, you know, it's got to go into 150 mil, so let me go ahead and instead of make this continuous, I'll make it like 100 mil. Well, no, I'll make it 50 mil. Well. Type that in. Okay, so I got it set to 50 mil, so, and this is the absolute limit. What the? Damn it, press it won't. God damn it, stop! Why the fuck did it do that? I only had it set at 50 fucking mil. I'm glad it ran into the copper. Oh, I know why. Because this thing is working in fucking millimeters. That's why. What a bunch of fucking bullshit. See, that's what I'm saying. These people write this software without fucking thinking things through very well. A bunch of dipsticks. But yeah, this is in millimeters. Even though I got the machine set in inches, this stupid program's still working in millimeters, and there's no way to change that. Now, I've been through that settings thing a dozen times. There's no way to change that. So yeah, you're working. So this is a bigger pain in the ass than it should be, because yeah, you're working in millimeters. So I gotta do it. Let's see, probably 4 millimeters, I guess. So, because that'd be about 160 mil. So I'll set it to 1 millimeter at a time. Piece of shit. Now I can't fucking believe that. Stupid fucking assholes. That's how you break shit. That's stupidity. Okay, that's 1 millimeter, I think. Well, let's see what it did though. Well, hold on. Okay, let me zero it. Okay, that's fine. Alright. Yeah, so 39.4, that's 1 millimeter, that's 2 millimeters, that's 3 millimeters, that's 4 millimeters. So again, that should be pretty safe given the fact we had a 100 mil wide tool, and it's not going to be 100 mil, it's going to put the position of the tool, the path is going to be only about 50 mil. Okay, and then you got that 50 mil inset, which is where we put our origin for the board. So 150 mil would be more than enough in theory from that, at least from that tool limit, so I don't have to worry about it crashing. Because see, we're still not at the edge of the board yet. So, really, if I could just get it about, I should use a camera more often. This is actually pretty helpful. It's better than looking at it with a magnifying glass. I don't know if I want to go down because that may crash and I don't want to break my drill bit since I got it set to millimeters. But I think that's about right. You know, so yeah, if I just went like another millimeter in, that should be sufficient. So that should be a good place for our origin. But the router will still be hanging off the edge of the board when the edge router goes through here. So it'll actually, there won't be a web left over like this part here. That'll be gone because it'll actually route probably off the edge of the board a little bit. But that's okay. I just want to make sure it's not going to crash into the other end. I want to make sure I don't have to shrink the fucking board again, because that was a pain in the ass. A little, well, not a terrible pain in the ass, but still it was more work than I'd like to have done on this. Making sure that board's not too long to where it hangs off the edge there and starts screwing with my height mapping tool and all that crap. So anyway, that'll probably be fine, you know, as a home position. So I'll go ahead and here. But I'll go ahead and you know, zero it here, and then I'll do an edge probe on it. Now, keep in mind when you're doing this edge probe that you want to make sure the drill bit, you saw how low that drill bit was before. You want to make sure it's not too far, because if you have it like, if the tip of it was like, here, let me zero this. Okay, so that's our zero. But if I were to start that routine, you know, when it was up about here, let me go ahead and put this back on continuous mode. But anyway, if I were to have, you know, started this from like up here, this machine will actually freeze up and generating an error, you know, if it goes too far without hitting something. So you want to make sure the bit is pretty low. You can change that setting if you want, but it's still kind of a safety measure. But make sure that it's not too far off the, you know, the edge of the board when you're doing it. You know, and then you run this little routine, and you know, then you got nothing to worry about. No worries. Okay, but at any rate, now that we got that ready, you always give your board a good dust off. And yeah, then we can actually, you know, because again, I've already auto-sized the grid. It doesn't hurt to do it again. I'm happy with these settings. So let's go ahead and press the probe button. I don't have anything that'll complicate the issue. But this will probably take about 30 minutes. The one I did yesterday took about an hour and it wasn't even done yet before I noticed it was running off the side of the board. Okay, and of course I'm not going to sit here for 30 minutes and making you see it, but you can kind of see, you know, that these little ticks here, that's what it's probing. So, these little ticks, and it's flying just a little bit above the board, you know, which I think you can adjust that transit height to. It's not going very high when it's doing that, as you can see. I think more people ought to make videos this way with a webcam and everything, if you're, you know, because you get the benefit of doing a screen capture and the benefit of having an external camera all at once. I guess I have seen some people do that before. More people should do that. It's actually it's the first time I've ever tried this. It's actually pretty convenient. Anyway, I'll come back once all these numbers are filled in. You know, you can see it's generating height data. Now remember, these are all in millimeters, and this negative sign is telling you it's minus 0.119 millimeters below where the origin is. I wonder why that's at 8. Yeah, that's strange. Normally that's at 0. I don't know why that would do that. Oh, it's probably because it's in a different location. Because our home is here, but our grid, I think, starts over here. So that's why I did that. Because, you know, it's not actually, well, it is here, though, and that generated along the edge. So I don't know. I'm used to this number being 0, because normally on single-sided boards I have my origin in the corner of the board, not inset by 50 by 50 mil. So, but still, this correlates. I'm just confused why that's off a little bit. Here, let me stop that because I want to make sure, you know, that there's not a problem with this before we go through and do this whole big ass grid. So let me go through the height mapping thing again. Make sure it comes out to 0. No, it's coming out to 0, so it's where it's supposed to be. So, okay, well, it's probably okay then. I don't know why it came out to 0.008. That's not a huge error, but it is an error. Yeah, see, that's, you know, 0.005. But that's like 0.039 mil, so it's like 39 millionths of an inch off. But normally it's 0. That's what's weird. It's always 0. But and again, that's not that big of an error. But at any rate, right here, you know, because every 1/10 of an inch, you know, 1 inch is, you know, 1 millimeter is 39.4 inches, which is 39.4 mils. So a 1/10 of a millimeter is 3.94 mils. So and 100th of a meter is 0.394 mils. So it's like, you know, almost 5/10,000ths or whatever. But anyway, those are just, you know, ways of like remembering things like that. But still, yeah, you can see the variation, you know, so this is anything but flat, but it's off by, you know, like this is like, you know, off by about, what, you know, 6 mil, you know, 5 or 6 mil, so that means this is about 5 mil too low. I mean, it's 5 mil, this point here is like 5 mil lower than our origin was, you know, our origin point being here. So it's all relative to that point. So this tells you just how off flatness, you know, your board is. And like this one, you know, shit, that's, you know, almost 8 mil off, you know, so that's a big dip that we have right there. But by keeping that in mind, it's possible, like, for example, if this actually had a hole you know, and it actually accidentally probed into that hole, and you were quick enough to stop it. You know, a lot of times if I see a hole, I'll actually take a piece of, you know, a piece of like nickel strip or something, just to stick it below the bit when it's probing over that hole. So it'll have an error in it that it won't cause the machine to lock up with an error message, but that way I can, you know, literally just go in and interpret my own value, because again, you can edit these values to be whatever you want. So if there's ever an error in it, you know, for some reason, you know, you can correct these values that way. So just FYI. At any rate, you know, I'm not just sit here blabbing for 30 minutes, so I'll put everything on hold and come back when this is done. Okay, the thing's done, and I learned a little something here. This took 37 minutes. This interpolation grid, as you can see, it is. So they got 20 points, 20 cells this way and 20 cells this way. So no, you know, let's make two separate grids for our program. One is this, and it has nothing to do with this over here. So instead of this being a fraction of the points between these points, like it should be, no, these are two separate grids that are overlaid on each other. So basically, this is bullshit. Now, let me see if I can correct this. Or am I going to have to do this whole thing over again? Okay, thank God I don't. Okay, so this, you know, allows you to adjust the accuracy of the grid. Now, since I did 10, I would like, you know, at least 20, you know, points, preferably, you know, 30 across. Not 300, but 30. Okay, so that'll be 3 to 1. So for every one data point there, it'll try to interpret that. It'll divide that into 3 separate points that it interpolates over. Okay, and we did this, you know, this should be like 90 at least, you know, with a 3 to 1 ratio. But fortunately, you can't adjust that afterwards. Okay, but that gives us 3 by 3. Now, if I did this as an 8 by 8 grid, it would be, you know, with the 20 points it had, it would be 20 divided by 8. So that would be about, you know, I mean, 20 divided by 8, you know, would be about 2.5 points per grid. So again, this is probably okay. So the interpolation grid does make a difference. You could just never tell before. I couldn't find anybody on the internet that could tell me what this thing actually was. So again, my assumption was it was using that as a grid between your points, which made sense. That's a lot of points, but why not? You know what I mean? But no, as it turns out, no, these are like two separate fucking grids. So it's best to make sure these are an integer multiple, you know, of these. So, you know, again, I'm using 3 to 1, so that's 30 by 90. Okay, so, at any rate, that's got our interpolation grid going. So that's a good thing to know no matter what kind of board you're doing, because I did not know that. Wasn't covered anywhere. The people that make this software write shitty fucking manuals. So, not very informative at all. Well, if you think that's bad, you know, that laser gerbil thing, that really sucks. But at any rate, yeah, I couldn't find anything on this, but that's what that's for. So, okay. But now the next thing you need to do is you need to save this grid, because I'm going to use this with multiple tools. Every tool on this side I'm going to use this grid for. Unfortunately, there's not a fucking save button like any sensible person would have, so what you got to do instead is you got to try to open a file while you haven't saved it, and it'll ask you if you want to save the information. So you press yes, and then you can name it as a file, and I usually name it as M, you know, like in this case, bottom, you know, MB for bottom map. Okay, and we don't want to open another one, so just hit cancel, and that saves your map. Now from that point, you're going to be confused. Well, how the hell do I get out of this? That's because you're in edit mode, so you got to switch back to your other view. And so this actually toggles between these two. Alright? The next thing you got to do is make sure you hit this use height map, otherwise it won't actually use it. So, let's go razor deal. Okay, and I'll show you where it ended up. You know, that's the last row, you know, is right there. So we're well clear. Again, my previous attempt, it would have actually gone off the edge of this, so that's why I had to stop it early. But this, yeah, my efforts to shrink it appear to have worked fine. Okay, so now that we've got that done, and I got my map saved, I'm going to go ahead and zero the tool with my little custom button there. Alright, so, you know, that's where we're at. And save that. Remember, I've got my drill bit loaded there to do our reference holes, and that's what I'm going to do next. Now, I needed to pull this file up so that I could do the height map, but that's not what we're going to actually machine right now. I'm going to pull up our little reference deal, whatever we called that. Let's see, what the hell was that called? PTH drill CNC. That's our PEC file. It's our alignment drills. So I'll open that up. So it's just 2 points. Remember, we've already zeroed our drill bit and stuff before we did the height map. So in theory, things are ready to go. Now I usually use a feed override, and on something like this you can probably disregard it and actually do it at maximum speed, you know, whatever its default speed is. So I should be basically good to go. Oh, I gotta load the height map first. Okay, so, and you gotta do this for every file you bring up. Load it and use it. Okay, so now we're pretty much ready to go. This stuff down here does not affect it when you actually send the file. It has no impact. This is just for jog. The stuff down here, it has no impact on the actual machining operation. This stuff does, because you can override its whatever its setting is if you want. So the only thing I really ever override is the feed rate. But you'll see that in the future. But let's go ahead and get this going. It shouldn't take long to execute. So drilling the 2 reference holes so we can later flip the board over using the thumbtack. Voila, easy peasy. Dust it off. Okay. And that took 28 seconds. So, so what I'm going to do now, I wish I had some kind of holder for this camera. Let me put this back in the bag where it belongs. What I'm going to do now is change out the tool to our router bit. Now, like I said, I'm going to use that V-score router because of the fine traces we're using. I haven't used one of these steeper bits with this yet. So, that's not the right one. I'm going to go for a 30 mil bit instead of the one I normally use. Shit. That's not it. Yeah, I think this is the 30 mil bit right here. You know, as opposed to the 45 degree bit I normally use. I don't think these things are marked, so I got no idea. But yeah, but again, it's a a triangular bit, so they're a lot sturdier than the other bits. So, out, hold your thumb on it so the bit doesn't fall out and break. So let me adjust my Z here. As high as it can go. Okay. Alright. Tightening. Alright, now that I got that done, what I need to do is re-zero it. Okay, we're at 0, 0, or X and Y. But I gotta zero the bit, and like I said before, don't start way up in the air like it is right now, so I gotta try to lower it until it's close, but not too close to the board. Okay, now I can run my little Z routine on it. Alright, I'm going to zero the bit. Okay. Now, let me load the previous file we had open. The bottom copper layer, because that's what we're now going to route. And I always like to raise my bit first. After that, just so it doesn't crash for some weird reason, because I've had that happen. It tried to just drag itself and break your bit in the process. Get a drill bit or whatever. At any rate, that's got, we're all set up to route. Now let me look at the feed rate here. I'm going to want to override it. Especially since this is a bit that I've never used before, I'm going to probably mill it at a pretty low speed. Normally I mill it about, here on the slider. But again, this is 29% of whatever you specified in Flatcam as the speed, which again I generally ignore. So I just use the default. It's still set as the default. But yeah, if you do it at this rate, it should be good. But this is why I watch it with a magnifying glass at first, just to see how it goes. Because remember, it's going to plunge like what 6 mil or whatever it was I set. So, but it's just a feed over right now. Before I forget, you gotta always remember to open your height map. Otherwise, you're going to be irritated. Okay, so I got set to use height map, and I opened it. Okay, so now in theory we're good to go with the actual routing of our first trace layers. And again, this is the one that's way more intricate. So the thing about it is too is that I'm not really sure if this board comes out, even if it works perfectly, comes out perfectly. I'm still not even sure I can use it. I'm still not sure if I can solder this without there being just a shit ton of bridges, particularly in these traces that route between pads. That's what I'm most worried about, because man, you got to use a really fine tip soldering iron for that, and again, with boards like this, they tend to bridge real easily. So I'm still really skeptical about how well this is going to come out, but we'll see. Even if the board works perfectly, it still may be a piece of junk in the end. But anyway, let's go ahead and see what happens. Looks like it's not going too deep. So that looks pretty good. That's why I like a brush. You can just brush right into it. Remember, we did 2 traces on this, so it's doing the first route, the innermost route first, and then the outermost half next. So sides we did these two, you know, an offset layer. See it well through it. Yeah, it doesn't look like it's too fast. It doesn't sound like it's loading the machine too much. But we'll see if this height snap again really worth the shit. Take a look at that, we'll see what's going on. Yeah. The trace is still there. It's probably way less than 25 mil, so, you know, again, it's kind of hit and miss with these Z-score bits. You just don't know what you're going to end up with. Because hell, that looks like a 8 to 10 mil trace to me that it's forming. There is still a trace left. Barely you can see it, but there is still a trace there. Again, if I were to do this over, I probably wouldn't have done it with such narrow parameters, but we'll see, especially when it comes between these pin routed traces. Now that's not very, yeah, that's not very wide. So anyway, I'll come back to it and check it after a while and update you on it. I'm having to dink with this a little bit. I just got through adjusting the Z-axis up a little bit by about 1.7 mil because it was just routing too deep. And also my bit, I guess I didn't tighten it enough, but for some reason it ended up being you know, like 10 mil too shallow for some reason. So I don't know. I'm going to have to check into that. I'm still in the process of looking at it. The last time I was routing through this, it was like, at this point, it was cutting through air. So it wasn't even making contact with the board. So, yeah, the bit had slipped, so I had to actually retighten it. These bits can do that when they start to heat up. They, something happens with the thermal expansion. And, you know, on the different materials, and the bits can actually become loose. I guess it got pushed in somehow. I'm not sure how that happened, but apparently that is what happened. And again, like I said, I also noticed it was cutting too deep because these traces were still conducted. They're just really, again, they're about like 6 or 8 mil. That's just not enough tolerance. So, yeah, I increased the bit height. Again, I've never used a 30 degree bit before on this machine. So, I'm still kind of learning what the proper heights are. Take a look at it. Yeah, that still could be wider, but it's at least wider than it was before. That's certainly way narrower than 25 mil, so in theory I had to stop it and restart it just to be safe. Because it's still a little too, you know, eating up a little too much out of my trace width. So I probably ought to take it up by another, I don't know, mil or so. Because again, it's already only going 5 mil deep, with 5 or 6 mil deep. So anyway, I might do that and rerun it just so it's a little better. even though I might end up having to retrace it again later, but I'll probably go ahead and up it. I'll show you the process that I use. Let me go ahead and board it up the drill bit, right? Yeah, I tend to just zero it, alright, but then I lower it, but you got to set your thing to like a very small incremental value, but let me go ahead and get it close first. Okay, that's probably close enough. Now let me go ahead and set it to 0.01 millimeter, and watch this indicator as I do it. Right now it's at 79 mil. Shit, that's a lot. Yeah, I don't know if I want to sit there and do that all day. 30 mil. Got 6 mil right now, so let me go to a smaller increment. Again, that would be another 1.5 mil, and hopefully that's enough to let me zero it there. And anyway, that's how you adjust your axis up in the positive direction. Now, if I were wanting to go lower, I would actually have to take the machine, you know, literally off the edge of the board and do it. Because then I can lower it below you know, where it was. See the negative value, it's negative 5 mil, but then I could go zero it here if I wanted to cut deeper. So it's a little bit of a pain in the ass because you can't directly enter values into these like you can on other CAM packages. On other CAM packages, I just enter a new number. Like on, you know, a package that I use a lot, you know, is Mach 2, for example. My K2 works with Mach 2, and you can do that. It's a lot better of a CAM package than this. But this isn't terrible with all things considered, but it's just a little bit of a, you know, it does have its quirks. So, anyway, let me go ahead and solder that off, or dust that off, and I'll go ahead and since I got things re-zeroed, let me go ahead and hit the thing. Alright, what I'll do here is I'll take my feed override off since I've already routed all this shit, and I'll just let it run full speed until it catches up where I was. And then I'll slow it back down to the 21%. If I had a high-speed spindle, I could actually run it at this speed, but since the spindle's not high speed, you know, you just don't want to overload your stepper motors. But a higher speed spindle would help prevent your stepper motors from being overloaded too much. So, but it's a low-speed spindle like this, you know, that's why you're going to start at low feed rates just to be safe, because then this is a lot of hours of work to put at risk otherwise. Now, I'm sure the more experience you can get, you know, but it still depends on the sharpness of your bit making. Your bits start to get involved. You want to slow it down too. So, you know, I was going to say, with more experience, you know, you could probably get to the point to where you have a feel for it, perhaps. But at some point, you'll start, you know, if you overload your stepper motors, you'll start skipping steps. You're going to really tough. You really won't like that situation at all. white powder, that means it's going through the copper layer. So anyway, I'll check back later and we'll see how this goes. Upping its feed rate a little bit, and it seems to be doing basically okay. It doesn't seem like it's overburdening it too much, and everything's up at the 40%. See how that goes for a little bit. It's been going on for about 28 minutes, as you can see here. So, you know, and it's only about less than a quarter done, so I don't want to make it on longer than necessary. So anyway, alright, progress report. See that we still got, I've upped the feed rate to 51%, but we still got like another, I don't know, 20 minutes left, less than 20 minutes. But see that, that's just come out fairly good so far. I might even be able to up the feed rate a little more than this. See what it looks like under UV. It's getting there. Yeah, I mean, we'll see. I mean, it's just we got a bit more to go, but we'll see how it comes out. Okay, by the way, as a rule, when you're doing double-sided circuit board design, you should choose one layer to have your vertical routes and a different layer to have your horizontal routes. So generally try to adhere to that, and you usually end up better off than, you know, than you would be otherwise. But there are times you can break that rule. But generally speaking, you know, you should try to adhere to it as much as possible. So anyway, just thought I'd mention that. Alright, so after 2 hours and 17 minutes, this finally completed itself. Let's see how shit turned out here. Well, hold on. Let me adjust the machine here. Hopefully I can go so far it causing the machine to miss a step. And it's hard to see with the magnifying glass. Brushed it off quite a bit. Jog forward a little more. Okay. Front looks good. Traces look intact. Again, they're over-routed quite a bit, but I told you that would happen. I just wasn't sure how much based on the 30-degree bit. You know, wish I could have done it a little more shallow, but still, it's just hard to say how accurate this height map is going to be, but it looked like it must have been pretty accurate here. I probably could have gone to a deviation of like 2 mils or so. I mean, it looks pretty good, with all things considered. I don't see any obvious breaks and traces or anything. Man, this UV light thing, I wish I would have discovered this years ago. I mean, this is really awesome how much this causes a trace to fluoresce versus this. This is under regular visible light, but it's just not as clear, as opposed to this. This is awesome. So, this may be an internet first here, I don't know, but using UV light to see how well traces route is pretty damn useful, I'll tell you that much. But yeah, I'm actually pretty happy with the results overall, even though it's a little over-routed. But again, that's why I use 20 mil traces. Imagine if it was 12 mil or something like that. I mean, these traces would be gone, a lot of these are so skinny, it's unbelievable. But again, even these very first ones that you see here, even these very first ones that you see here, are very skinny, but they're still conductive. I continuity tested them already earlier, but you didn't see that on video, but I did continuity test them. The rest of these are actually way thicker than those, so I think it came out pretty good, surprisingly. But I can see some adjustments being made in the future to make a shallower route and so forth. The tip itself seems alright. It doesn't look like it broke or anything. So, so that's good. Okay, well, alright, now it's, I guess, time to, it's like fucking 1:49 a.m. my time. So, I'm up rather later than I would have been had I not made a video. I would have been done with this by like 9 p.m. I'm sure. But anyway, let's go ahead and get set up for the next step, which is to do a route. So I'm going to go ahead and, like I said, the bit is up there quite a ways. Well, let me go ahead and raise the Z a little bit. Okay, that's good enough. So I can change the bit. Move it forward. That always helps. That's enough. Okay. Position this camera. Okay. It's like a $10 camera off Amazon, but it's actually, a 1080p camera, so it's better than what you might get. You can't believe what those motherfuckers tell you their resolution is. Okay. Alright, so it's time for the, it's got a magnet. It definitely has it's a DC motor. It's got a magnet in it, so your tools stick to it every now and then. Anyway, let's find my 062 bit here, which I've used the shit out of this thing already. I've routed lots of, a dozen boards or more. But hopefully it'll keep holding up. Because router bits, I don't know if you can see that or not, but they have like little teeth on the side of them. So they're not like end mills, which have here I'll show you an old router bit I used to use. But they're not like end mills, which are fluted, and that's the only way they have to remove material. These have actual teeth on them. So an actual router bit is toothed. So that way, it really doesn't matter. matter so much what the flutes are. If it has flutes, it'll still remove material, and that's what we're dealing with here and in this, like, set that I bought. They got a bunch of teeth on them, so they tend to last longer than normal bits for that reason, but I still have a life limit to them. But I just push it in until it won't go anymore, even though honestly if you really push hard it'll actually go way deeper than this, but just with a bare amount of force, just push it as far as it wants to go, and that's where you start tightening it. And again, tighten it fairly tight, like that last bit I used that I just took out of there. Well, I didn't tighten it that well, so it came loose during the process. So anyway, I got the bit loaded. Alright, so what I need to do now is, and that's at 0 point. Now what I want to do is lower it, like I said, to where it's within range, but not quite hitting the surface. And I want to do my little Z probe tool. Okay. And wherever it hits, that's where I'm going to zero it. So I zero it for that tube, that tool. Now I need to open the edge routes layer, because we're going to now route the edge routes of the edge of the board. Let's see. Cuts Gerber. This is edge cuts Gerber. This is it. So you can see, we're going to make this many passes. That's like 4 passes. Remember, 80 mil deep. So we're going to make 4 passes at 20 mil a step. So until it's done with the board. Now I usually set the feed rate down to a lower level, like about roughly 20%. You might be able to go faster, but remember, you don't want to cause your stepper motors to miss a step, then it'll really fuck up the board if you do. So it's better to be safe than sorry, especially on a board that takes this long. Now if you're doing a smaller board, you can experiment with it, but honestly, something that takes like over 2 hours to route the traces, I don't suggest you experiment with that very much, unless you don't value your time as much as I do. But anyway, that's got that, so I gotta remember to open the damn map file, okay, and remember to use height map, okay. And so since we got our feed rate set, our tool loaded and zeroed, we're ready to actually send it to the unit. Get ready on the panic button. See, it's going along an edge. It's outside of our perimeter, so it's not actually routing anything right now. So, and I expected that to happen because of where we, put our origin and everything. I figured it was gonna, not, make contact with the outer side of the board. So that's what I told y'all. It's not gonna form a web like this on it, because we, I'm so concerned about the board not being long enough. I wanted to, err on the side of caution. Now, it says this will take about 31 minutes according to this down here. So, but you don't want your feed rate being too much, because this is a 20 mil cut it's taking. So, because of that depth, you want to be careful. Here in a second, it'll start cutting into the route. Now, I do want to see what happens when it hits the solder gun. Solder tool. I don't think it'll be a problem, but it might be. Anything happening with the noise or anything, so probably fine. So yeah, it looks like it's going pretty good. So anyway, I'll check back in with you in a while. pass. I've upped the speed to like 41%. 22 minutes and progressing 15 bit rate. Alright, we're finally done. It took like 26 minutes and you can see what the results are. What? It's a fucking brush. Let's see. Alright, the brush is missing. Hold on a minute. Alright, I found the brush. Normally what I do is I try to take a piece of copper clad when I'm dusting this shit off. If there's a lot of dust, and I use this as a dustpan. You know, you definitely want to get this thing dusted off because I'm about to flip it. So I have to flip the board. You don't want a lot of dust, so you're going to apply more tape to the bottom of the board after you flipped it. Now, what I'll do, if I can find it, is I'll use a screwdriver. Now let me go ahead and 26 minutes, okay. Let's advance the platform here a little bit. Now I won't need a router bit in it next time. We're going to need a V-score. Like I said, I'll probably use the 45-degree bit next, even though I could use the same bit. But let me go and try to pry this off. Like I said, this banner tape is very strong, but it will pop off. Another thing, it's not like totally permanent. And see, here's what you end up with underneath. And as it turns out, I only had about one stripe going down the middle of this board. I thought I went left to right. As it turns out, I guess I went up and down. But yeah. But anyway, I got to peel that off. But definitely before I do that, I'll do a good dusting. Here, let me make this in the forefront there for you. Okay. Get this dust out in the air so I can get like lung cancer or what the fuck ever you get from fiberglass. Okay. Now it looks nice and clean. Now I gotta peel the tape off the bottom of this. So that'll be tricky. Let's see what I can do here. So we just gotta get it started. Like I said, this is great tape because, you know, it's super strong, but it isn't unreasonable to remove. Totally unreasonable. Okay. And Bob's your sister because he's gay. Damn it. Fuck. Okay, that fucked up my gloves. At any rate, you know, let's get the tape off. And this is going to be this hop side. Now I do advise, that you get your little, flat bastard file like I talked about in an earlier video. Go around these edges, because you want this thing to lie very flat on your board, because if you don't, you don't want any kind of give that the tool can press down on, because that actually, okay,